Hello, all, and welcome to Dev 302, Building and Managing GraphQL APIs. I'm Dave Feuer, and I'm joined by Greg Brail. We're a part of the Apogee team, and we're super excited to present this to you today.
Hey, I'm Greg. I'm also part of the Apogee team, and I'm also excited.
I guess the first thing I wanted to get out of the way is that, sometimes in technology, we can overemphasize how new technologies and exciting ideas are dominant in the conversation. And so I just want to be clear, and I think both Greg and I share that, REST is still the king of APIs. If you look at this graph, which is from Google Trends, it clearly shows that REST is still the king of APIs and still dominates interest. And so while we're here to talk to you about GraphQL and some other API styles, it's important that we realize that REST still has a very important and very prominent position in building and designing APIs for the future. If we're going to contrast GraphQL and REST APIs, I think there's three specific areas that we'd want to talk to you about. The first is that both GraphQL and REST offer a consistent way to access different types of data. So while GraphQL and REST construct things differently, construct requests differently, and get responses differently, fundamentally, they both allow you to access data. GraphQL offers a query language that's different, of course, than the REST query style, and that can potentially work across many types of backends. But fundamentally, they're both requesting data and they're both offering a consistent access pattern for the data. The second is efficiency. While it's possible to construct REST APIs in an efficient way, GraphQL is specifically built to avoid overfetching or underfetching data. The query language is super powerful and allows you to request just the data you need for your client, whether it's a mobile client, a web client, or another style of application. And the last is implementation complexity. Implementing an HTTP server to parse URLs and return data from a variety of sources, that's a straightforward task, and many people do that in their environments today. But GraphQL requires specific software and a specific engine on the server side that can parse the queries and break them down into execution steps. And so that's a significant difference between GraphQL and REST. To recap some of the benefits of GraphQL, I think data load control and granularity are super important. The fact that GraphQL has a single endpoint and allows you to really execute one request and then have the fan out on the southbound side, make a whole bunch of subsequent requests and return that is very, very powerful. It also means that if one resolver fails, other queries can still succeed and still resolve and bring back useful data. In the REST world, REST doesn't necessarily work that way. REST has multiple different endpoints, and so each query to each endpoint has to be treated individually.
So, could you maybe talk a little bit about as a software engineer? Maybe I'm building an app. Why would I choose GraphQL, and why would I choose REST?
Great question. I think there's a lot of apps, specifically apps built using the React.js framework, that really benefit from the fact that GraphQL will only get the data that's in view. So that, for instance, if you are tracking sports statistics, you only retrieve the sports statistics for the player that you're looking at, or you only receive the sports statistics for the specific table that you can view in a mobile app. As opposed to REST, which might require additional APIs or additional parameters to accommodate all the different views that might exist in an app and create individual APIs for those different views. So being able to leverage the GraphQL query language to really only get the data that you need for that specific user creates a certain amount of efficiency and a certain amount of developer safety where they know they're getting the data that they expect when they expect it versus having to make multiple calls in order to fill out whatever table the user might choose to view in that application. Does that make sense?
Yeah. So with REST, I'm used to using an API gateway like Apogee, where I might have a couple of customized versions of my API for different devices because I want to have it be more efficient. Are you saying with GraphQL, I have more options, I have more flexibility in the data that I return to my client?
Absolutely. Along with the control that gives you the ability to request exactly what you want and retrieve exactly the data you want, also comes a tremendous amount of responsibility, right? Suddenly you have to figure out upfront what data you want versus simply calling an API. That being said, with that control comes a certain amount of developer safety, as we said, where calling that one API just becomes very simple and very easy. And that query language is really what provides that control in the rest in the GraphQL world.
So a mobile developer might really like the fact that they can choose exactly what they want, send one request to the server, and get it all back at once, rather than having to navigate a whole forest of individual URLs in order to get the same information.
Absolutely. Yeah. That's a great point, Greg. The third point is that whereas in the past, GraphQL required a whole bunch of specific glue in order to work with different programming languages and different frameworks, we're really seeing a proliferation of GraphQL client libraries. So GraphQL really is available as a polyglot protocol and is no longer simply reduced to a few languages or a few frameworks. GraphQL is really fairly open and really portable. And so we're seeing a change, a shift in adoption of GraphQL as a result of that. So, I think if we take a step back, we'll see that there are really two communities of use for APIs. There are API programs, which are tight knit teams where the client and server are a tight knit group, or sometimes they're the same person that's developing both the server application and the client application. And then there are developer programs, which are really about creating APIs as products and exposing those APIs to those different communities so that different developers can build their own front ends or their own application servers that leverage your APIs to create different value propositions. So, in that specific instance, it could be a different business unit, it could be a different company, it could be a partner, but you no longer have the same scope of control over both the server and the client, and that's a significant change. That's a significant difference between API programs and developer programs. That in API programs, you really don't have to be as strict about design of your API because since you control the client and the server, you can sort of assume a certain amount of knowledge and mediate between that on your own. But when you have a developer program, the clients don't know what you know. And so you have to make sure to actually productize your API in such a way that makes it discoverable and accessible and makes it easy for developers to leverage and consume that API in order to drive business value, not just for you, but also for their application.
So
And
if I'm using GraphQL, how do I know a developer is not going to do something crazy and query a bunch of data they're not supposed to get?
exactly, Greg, perfect setup. I think that's the fundamental challenge is that we don't. We don't know what clients are going to do. In REST, we know what APIs we expose, and so we know what clients are going to request because that's what the API is. The API exposes that resource. In GraphQL, when you're exposing all of your resources like a graph, clients can really request whatever they want. And so we're seeing GraphQL struggling in that area, in the area of developer programs, where it's been super popular with API programs. And I think what we're doing with Apogee is super exciting here in taking all the learnings that we've had from productization of APIs and bringing them over to GraphQL. Greg, why don't you talk a little bit about API productization and how we're bringing that to GraphQL?
Awesome, thanks. So if we look at this chart, this talks about a lot of the things that an API team needs to think about when they're trying to turn an API into a product. Taking something that's just an HTTP endpoint with some JSON and turn it into something that developers from different organizations and different companies can consume. And a lot of these things are things that if you've been following the world of API management or seen any Apogee things before, you've probably heard of about a lot of these things. Time to first hello world, for instance, that's what that acronym is for, is a really important metric for an API program if you want developers to adopt your API. Having a community, having standards like OAuth as part of your API, and having things like developer portals. And this enables really one of the most important things that's a difference between an API used by a small team and a developer program used by lots of developers in different organizations is the ability to do self-service. And when we talk about API productization, a big part of it is self-service. How does a developer who wants to use your API find out about the API, figure out what the API does, and get credentials? If they can do that in a few minutes, your API is ready for consumption by almost anyone in the world. And that applies whether your API is a REST API of the style we've been talking about for years and years in the world of API management, or a GraphQL API. Now, when we talk about this, we talk about control, security, observability, and governance. And in the world of REST APIs, we often do a lot of these things based on the fundamental principles of REST, like URLs and verbs. We'll do things like we'll say, if you've got credentials for the API, you are authorized to invoke certain URLs, but not other URLs. Or perhaps you're authorized to get all the URLs, but if you want to post some of the URLs, you need a different kind of credentials. All of these same things are going to apply to GraphQL. we're going to ask a lot of these same questions. So when David talked about making a GraphQL API ready for consumption by developers, the developers will love it because now I can do anything. I have access to your whole schema. I can query all kinds of stuff, and I can build a great app. And what I've said for years and years about this stuff is that it's not just that you have to worry about an attacker or someone who's malicious. You also have to worry about people who just make mistakes, right? Like, oh, I didn't realize that by executing that GraphQL query, I would download 10,000 rows of data from the database and clog up the internet and make my mobile device crash. Now I know that, so I know I have to include a parameter, but wouldn't it be nice if we could put some controls in front of the GraphQL API so a developer can't even do that sort of thing by accident? So what we're doing at Apogee is we're starting on a journey of figuring out what we need to do to make GraphQL APIs the same kind of first-class APIs as the REST APIs and the other kinds of APIs that Apogee traditionally supports. So in the traditional world of API management, we have this chart where we have API teams build APIs, developers build apps for APIs to create user experiences for end users. And that transition from an API used by an API team to a developer program is what this is all about. The question is, when we are working with GraphQL, how does this differ from the way it looks for a REST API? And the answer is not very much. All of the same principles apply. The developer wants to be able to discover the API via self-service. They want to get credentials. They want to use the API. The API team wants to have control over who's allowed to use their API and how much they're allowed to use the API. Are they allowed to use different parts of the API for different purposes? Is there a quota that stops them from using the API too much? Are there security rules or audit rules? Is there even a billing plan associated with that API? We want to be able to do all of these things for GraphQL APIs, which means that we have to not only look at URLs and verbs, but we have to look at the structure of the GraphQL query. And we have to understand when you make a query, what is this query trying to do? And as an API team, what kind of things can I let the developers do? And you can do this by having lots of different GraphQL endpoints. But one of the advantages of an API management system is that it allows the API team to be very sophisticated in turning those APIs into products. So if they want to launch with an API that does 5 things and sell it to customers for a certain price or for free, but then they want to add 2 more things, but they only want certain customers to be able to do those things. And then they want to add 1 more thing that only a few customers can see, but no one else should find out about. You can do all of this in your API management product without changing your API at all. You do this by restricting, in Apogee, you do this by creating something called an API product. And an API product basically specifies which parts of the API are available to which kind of consumers, what kind of quotas on them, and we can attach additional data to it that we can use to make other decisions. We want to do those same sorts of things with GraphQL APIs. So if you look at what we've added to Apogee, Apogee now has a way inside any Apogee proxy to parse a GraphQL request. First of all, just to reject it if it's invalid or even do schema validation. That can be super valuable because it means that if you have malicious users or developers who are still learning the API and making mistakes, Apogee can nip all of those invalid requests, right in the Apogee proxy and not even let them get to your backend server, which takes load off your GraphQL engine. But Apogee can now parse that query, understand what it's trying to do, and make decisions. So a very simple thing you could do, for instance, is say that certain developers or certain applications are only allowed to execute queries against the GraphQL API, whereas you have to have a different kind of credential and possibly approval from the API team in order to make mutations, which means basically we can very easily separate the read-only API from the read-write API. And then we can do more. And I think what we're doing in the future is we're looking at what more we can do. So for instance, we also, now that we understand the shape of the API, we can put a bunch of information into the Apogee message flow. We can then use other policies to make other decisions. So it gives a lot of flexibility for you as a developer right now to build some interesting API, GraphQL API related access control and other decision-making logic into your Apigee proxy. And it's going to make it possible for us to do even more with this in the future.
And Greg, do you see this affecting how enterprises are able to position GraphQL APIs for consumption? Like, is this something that you see helping application developers build new experiences using GraphQL APIs?
Yeah. So if you're an application, I mean, back, you and I have been around the world a little while. Once upon a time, it was considered terribly bad form to expose your relational database directly to developers because developers might be able to do something like select star from customers, or worse yet, delete star from customers, and overwhelm the database, or execute some ridiculous query that is nested 17 levels deep and joins 12 different tables together and slows down the application for everybody. So that's where three-tier computing and transaction processing monitors and all these things came in. Same thing with GraphQL. If you just put a GraphQL API in front of your core data and give access to developers to get at it directly, then you have to have some trust in your developers that they're not going to execute queries that cause performance problems or security problems or compliance problems. So if you have something sitting in front of that GraphQL API that's able to look at the queries and make decisions about what's allowed and what's not allowed, I think it makes it easier for an enterprise to be okay with the idea of using GraphQL for critical data.
Awesome.
And with that, we have a demo. You're going to listen to me, and what we're going to do is we're going to show some of the new GraphQL features of Apigee and what we can do with them. I'm going to start with an example of a mobile application that uses GraphQL. This application is a product catalog, and it makes one API call to get the product information, plus an API call for every price and every stock information. So as you can see, when I refresh the screen, we have a lot of these blue circles that show API calls being made. And when I click on an individual product, we make 3 API calls to get the result. However, I can also switch my application to take advantage of GraphQL. In that case, it makes one API call to my backend. It's querying the exact same database tables. In my case, it's even calling the exact same gRPCs, but the mobile app is sending one request to the backend, and the backend is fanning all of that and returning one response. The result is quite a bit more responsive. There's only one API call required to get all the product information I need. When I scroll up and down, it's nice and zippy, and there's none of that refreshing going on. So as you can see, GraphQL can be a very effective way to make an efficient and snappy mobile app. Now that we've looked at the app, let's actually see what's going on with the API under the covers. Underneath, of course, I have a GraphQL API. And I can do some things in this GraphQL API, like, for instance, get a list of products. And like in all good GraphQL APIs, I can merge data from different data sets, I can sort, I can decide how many. And I can get information about an individual product. And once again, I can decide exactly what fields I want to see or don't see. And in this particular case, this particular GraphQL query is being secured via an API key, which is being enforced by Apigee. Using this particular API key, I can also try and get information about the price of an item. And if I use that key, here's my query to get the price, you'll see that I get an error. This is coming from Apigee, because Apigee parsed the query, it saw that the top level selection set was called price, and this particular API key is not allowed to make that query. However, if I change the API key to an API key that uses a different API product, I now can get the price. Now that we've seen what the API looks like, let's see how it works in Apigee. First of all, Apigee has always had API products. They're key to API management because they let you package up an API without changing the back end into different combinations of functionality, different quota settings, and even different aspects like security depending on who's consuming the API. We've added GraphQL support to API products. So now, in addition to filtering on URL paths and verbs like we could before, we can also filter on, for instance, the GraphQL operation type, like whether it's a query or mutation. And we can set different quotas for different products like we always could. So for instance, you could set it up so a certain API key or a certain set of applications that use OAuth might be allowed only to do queries, or they might have a different quota than another set, and they might even be restricted based on the name of the GraphQL operation. Now, the way this is enforced is in the proxy, of course, and we have the first part of functionality to do this is our new GraphQL policy. First thing it does is parse the query to make sure it's valid. It can also validate the schema if you'd like. And then it sets a bunch of variables that we can use for other things. For instance, it's used in the check API key policy to enforce the API product logic that I just talked about. I wanted to go a little bit further in this demo and use the name of the selection set, which is the top of that query, to determine which API keys could query which parts of my GraphQL schema. And I did that using some JavaScript. I set a variable in the product that specifies what top-level selection sets are allowed, and I used a variable that is set by the GraphQL policy, which contains that information. After that, a little bit of error checking follows, and some clever but simple JavaScript that simply looks to see if the name of that selection set is in the product. That's all there is to it, and now I'm able to have some very interesting controls on my GraphQL application. So we've just seen a demo that shows how you can use the new GraphQL features of Apogee to parse queries and understand them and have additional logic to make decisions about those to make your API more ready for the enterprise. Over to you, Dave.
Thanks, Greg. That was awesome. We're super excited about GraphQL and our ability to bring it to our customers and prospects to build new apps and experience with this new technology. Please go to cloud.google.com/apogee to try it out. We'd love to hear what you think. Thanks for joining us today and have a great rest of the summit.